Without further ado, Dr. Kennedy.
Okay. Well, what I've been messing with is called a dell. This is the standard garment in Mongolia. I have two. This is my light one, kind of a little fancier, nice color. And I'm sure I haven't tied the belt on right because they would always do it for me. So it was done right. And then I have a real heavy one that is just warm. And you'll notice me wearing it maybe in a couple shots. I was given that for the field work we did so I didn't get cold. I want to start by just thanking you all for coming. I'm thankful to the school and South Dakota Broadcasting for public broadcasting for doing this. And I've been going to Mongolia, I think 7 years in the last 9, and it's been quite an adventure. Never planned any of it. Mostly just it would happen. And I need to start with M.R. Hansen. Some of you probably know M.R. very well. He started by going in the year 2000, and he held the first concrete conference in Mongolia in 2002, and he started recruiting students. And 2 students he brought over did not want to do concrete. They wanted to do water, environmental. And so they worked with me, and they were very good students. In fact, one of them's a PhD there teaching at Erdnet technology, and then moved to the Erdnet copper mine. And the other one is the environment and safety officer for the largest copper mine in the world right now in Mongolia. So they're doing very well, and I'm thankful to them. And they were communicating with me fairly regularly, come over to Mongolia. And you know, I was pretty busy, and I don't know, I was a little nervous about going. And summer 2011, everything fell into place. I had some great work to present. They had a conference they wanted me to come to, so pooh, off I went and presented. And what I found out when I got there was that they had just initiated an integrated water resources management master's degree among their 3 top universities. They have an agricultural university, the National University of Mongolia, or NAM, which is science-based, and MUST, the Mongolia University of Science and Technology, or the engineering arm. And they had a master's degree. And so I met up with a couple people and just started looking at this. I said, wow, this is me all over. Came back home, we had developed a white paper, and I developed a proposal, and Fulbright funded me, and I went over in 2012, and I lived there for a year. And took a little bit to get connected, but wow, what an amazing ride it's been, and an adventure. So I'm here to share that with you tonight. There are the trips, the Fulbright from 2012 to 2013. I went back in 2013, we continued our research, we continued it in 2014 with the first group I worked with, and then in 2015, got an email from Sonnen Hishig. She's a biologist that I connected up with to do environmental low flows. And she says, I got this email from a guy in Kansas. I can't come. What do you think? So they were doing a small workshop to look at studying rivers, potentially in mountain steppe regions, ecoregions in different continents. It was a macro scale proposal to NSF they were going to work on. And I said, oh, you got to tell them what you've been doing. And so she said, do you want to go? And I said, well, ask them. 3 days later, I got an invite to go. Sat around the table with 18 ecologists, biologists, and I'm an engineer. And I'm talking about what we're doing and what we're working on and trying to do, and they were enamored, and we got a $4.2 million research project for over 5 years to study river systems on 2 different continents. And from the literature I've been trying to find, no one has done that scale of work before. And believe me, it is challenging. So, South Dakota Mines, Fulbright, and National Science Foundation have made this possible. So, how do you get there? The first time I flew to Detroit, and then from Detroit all the way to Incheon, Korea, and then from Korea to Ulaan Baatar. The last time we went, we flew to Denver, Denver to Seattle, Seattle to Narita, and then into Ulaan Baatar. When I first went, you either had to go through Seoul or Beijing. Wanted to avoid Beijing because we always had to bring some equipment along. And they aren't very kind to equipment in Beijing, period. But no matter which way you go, it's 30 plus hours. Sitting, resting, sitting, moving. It's a long trip. And I think maybe I'll share that in a little bit. So that's how you get there. And I want to point out a couple of features in the continent, or the country, that I'll be referring to. Note there's the boundary, and this is Russia, and this is China. They are locked by those two countries. Imagine that, if you had to live between those two very dominant type of countries. Sometimes people ask me, well, Inner Mongolia, what's that, or something. Inner Mongolia is the portion of Mongolia that's in China, and China still governs that. Mongolia is its separate democratic country, all by itself. Ulaan Baatar is the capital. I started there, and then Erdenet is where they have a big copper mine, and I would ride the train between those two places. The train, you'd get on at 7:30 at night, I think, is that right, Mary? And we'd arrive at 7:30 in the morning, and didn't have to worry about these crazy roads and narrow roads and potholed roads and the driving. So it was very pleasant. We met a lot of neat people. I'll talk about the mountain ranges. The Altai Mountains is this range here. The Khangai Mountains are here, and the Hintai Mountains are over in the east. And big portion of the country is the Gobi Desert. Up around 35% of the country is Gobi. 15% is forest, and the rest, 60-some percent or 55%, is steppe. That's a meadow, a grassland, at a high elevation. And we were using the ecoregion of the steppe to study rivers. So we're comparing them to rivers similar ecosystem in the United States. Here is Ulaan Baatar. The whole country, there's facts on that sheet. I'll try to remember them, but I don't remember them all always, so you have some of those to go with. 3 million plus or minus people in the country. 60% of them live in one place, the capital city, Ulaan Baatar. And it's only designed for 300,000 people. Imagine that. What I struggled with sometimes is, they might have 3, maybe 4 lanes of traffic, or 4 lanes to drive in. There'd be 6 cars, and if there was space for a car, they put a car in there. They drive where they want to drive, and I think that comes from living in the countryside, because there are no paved roads in the countryside. There are no fences. You just drive wherever you want to. And if you want to get lost, that's easy to do. But I was talking with a few of you. Russia saved Mongolia in like the early 1900s, like around 1911, 1915, and then helped them develop a Soviet type of government. In fact, the Soviets ran it. They ran the government and controlled the people, how much livestock they could have and all that, until about 1990. And then Russia left. And they left behind a lot of degraded utilities, infrastructure. It was really worn down. It wasn't in very good shape, and it still isn't in very good shape. They're a democratic government since 1990. That's only 30 years. How long have we been a democracy and grown? That's a lot of difference there. So it was interesting to be part of like helping write their Clean Water Act. They were just starting to develop that stuff, using Russian background all the time, and it wasn't always the greatest, but it was fun to be part of. Their clear challenges are the infrastructure, air pollution, traffic, and a GER district. The climate is huge. I mean, I got up in the morning, you know, January, February, it's 38 below, 40 below, and I would bundle up. I would put my glasses in a case and wrap my face and everything. And I'm walking, and here's a Mongolian. Some of them don't even have hats on, and they're, you know, one kind of moderate jacket, and I just go, wow, they're resilient. You know, they're used to their climate, but it is really cold for a long time. 6 months is their winter, and the highs would be minus 25. So you'd actually feel the difference walking back home. But this is an extreme event they call a Zud. And as you see here, it's happened about a dozen times. 1940 to 2015, 20 million livestock animals have died. There's only 3 million people, right? So what that has forced is a movement of nomadic herders that just are giving up and going to the city to make a living. And this is called the GER district. It surrounds the major city. There's no water, there's no power, there's no sewer. And they burn coal and wood in the wintertime, and so they have terrible air pollution. And your heat in your apartment, you don't get to control it. It's either on or off. It's hot air, steam, that the Russians, you know, they just pipe it in everywhere, and then they turn it on in October and they turn it off in May. And that's all there is to it. And you're subject to the elements as they be. So I would try to cool it down. I was about 6th floor in this apartment building I lived in, and you open that window and you could taste the particulate in the air. So it wouldn't stay open very long. So it's a real challenge for the people there. And I think of that population, 70% of them are 35 or younger. And the lifespan expectancy is age 66. So they have challenges. But where does everybody go? I learned right away that when there was a vacation or when they finish spring, summertime is like 2 months. Bye-bye. And they are bye-bye. They go to the countryside. That's their roots. And in the countryside, it's quite amazing to see how resilient they are, how tough they are, how simple they live off the land. And so there's a shot of the countryside. Did I move that? Nice picture, some mountains in the background. Very arid. They don't have a long growing season, so the grass and grazing is pretty hard in places. This is Mary. She came for the last 3 months of my Fulbright, and we were doing a project work, and we had a friendly camp goat that started hanging around and was pretty friendly. This is the names I just don't remember very well. I worked with him at the Erdnet mine and the Salang water supply, and this is his family's home, and we went out there and stayed a weekend and enjoyed it. He was starting to try to raise pigs, and it was amazing. He had 2 big hogs, but he had to build everything. This is one of the more power places. You can see his solar panels there. That's all the power he has. Really doesn't run refrigeration, so there isn't refrigeration. This is a nomadic herder that we stayed with when we were getting data on the ore home. This is his GER, and I had my translator, Sonen Hishig, actually my colleague, and we were talking about floods on the river and stuff and going back and forth for hours. And when I left there, he grabs me and just pushes his nose right to my face, and And just, it overwhelmed me. And Sonnen Hishik says, wow, that doesn't happen very often. So people are really great to interact with if you're honest and really immersed in who they are and what they do. That's the heat, that's the stove, that's everything in a ger, not a yurt. Well, yurt is a Russian term. Ger is the Mongolian term. I like to use ger because that's where I spent my time. We saw all kinds of things. Goats, yak, reindeer. I have another shot of where we were at on those reindeer. But the countryside is pretty interesting. Here's another shot of the stove, and then you just lay out and sleep on the floor, or sometimes they had benches along the sides. This is an interesting picture, and that's me going over field notes. But this is a young boy who's ended up teaching me how to churn to make arid, fermented mare's milk. So this barrel is full of mare's milk, and they're just churning it every once in a while. And it becomes a very alcoholic beverage that they love to drink. And I know the students that work with us, we need to get some arid. and we would pick some up. And I learned that if you get it in summer, watch out. Because the heat and stuff really can make it sour. I tried some in October when it was cooler. It doesn't go as far. It was okay, but just a teeny bit. Simply, their foods. If you serve a meal to Mongolians and it doesn't have meat, lots of meat, you're almost insulting them. It's like meat is their diet. They just have it all the time. And I had to get used to that. Of course, I don't mind meat, but I did have beef and goat and sheep and yak and horse. I didn't have marmot. I turned that down one time. My students were having a marmot cook, and I just said, oh, I think I'll pass on that one. And then we did a big travel once, and it was my first trip out into the countryside. And we got there, and they were going to serve sutese, and that's milk tea. So this is milk that they harvested that morning, and they warm it because they don't have refrigeration, and they down it a little bit with water and some tea or leaves that they have from the region, and they serve it very warm and in a bowl, like the two bowls up there on the table. That's the size of the serve they give to you. And I tried the first sip and I go, oh wow, that is so good. Think of drinking creamy, buttery milk. It was so good, and I started drinking it, and then it just hit me, oh, I better slow down. I'm not used to this kind of richness. But it's very common drink, the sutese, milk tea. One of our favorite things to eat, we usually call them dumplings or something. It's called boules. Boules is common there along with mutton soup. And horseshoe, you ever had an apple turnover? Well, theirs is a meat turnover. And it looks very much the same, and they fry them up, and they put them in your hands right out of the pan, and you flip them back and forth because you're supposed to take that heat as energy into your body. And it's quite interesting. Just some more pictures of animals. The horses out there, you think they're running wild, but someone owns them. There's no fences, but there's a herder that's his animals. And cows and sheep, and then the camels. They usually are in the tree, shady area, but saw lots of camels out there. And I don't know if I mentioned, Mongolia is the 5th largest producer of cashmere in the world. And so they have tons of cashmere products and factories, and that's grown. And plus they sell it to a lot of other companies that produce cashmere garments. It's a big producer there. As well as the other big piece of the economy in the countryside is how many animals do I have? They used to be restricted by the Russians when they managed it, and when they left, herds just exploded. And there are some areas that are pretty grazed down in places. Here is a shot of what a river valley and a countryside looks like. That's actually our campsite. We were on this river collecting data. We hiked up here and just beautiful vistas and the mountain steppe. You can see quite a ways. It's a beautiful country. And then Huskul, anybody heard of Baikal? It's in Russia, right? It's the largest natural lake in the world. Well, 80% of that drainage is in Mongolia. It's called the Seleng River Basin. And this is the third largest lake in the world. And it's just upstream. And it's formed by a geological transaction and slide or rift. It's not a glacial type of lake, which you might think. But it's, I got my notes. It's 1,600 meters long, 280 meters deep. That's like 800, 900 feet. And there's an old ship that sits there. We got to ride on it, that the Russians used to transport material back and forth using Huskul Lake. And the other thing I want to point out in these pictures is this is the river coming out of it. It's not dammed, it's a natural outflow, but this is a tributary. That's the road and those are cars. There's no water in that drainage right now. Their rivers are huge. I've never worked on rivers so big. And one thing I don't know if they fully are aware of is how much storage is in that alluvium in these valleys. And I think there's a huge amount that's yet to be understood and developed. And then looking downstream, it's just, we use this crazy term called anomosticized. It's just got multiple channels because it's so flat, has a lot of gravel and cobble and material that it can't carry until it's a high water flow, and then it drops it all back out again. A lot of their rivers are pretty wide like that. Then the other thing here is, I'm not sure if you can see it really well, but there's a little disturbance there and along here. They have what they call ninjas. They're herders that have taken to mining and what do we call that? Panning type stuff. And they use tough chemicals and they just go to these gravel riverbeds and they stop at a place and try to find gold. And that's how they try to make their living. But some of them are getting health problems. They burn tires for heat and to extract stuff. It's not a very good environment. In fact, it's supposed to be illegal, but people still do it. And when we're at Huskul Lake, and how we got to Huskul Lake is this was at the end of my Fulbright, and so my Fulbright was to teach a course and do a research project. And I got there and they didn't have the course on their schedule, and the person who I communicated went to Germany to live, and I talked with the right person to get the course there, and I think they coaxed a couple of people into the class, and so I had 4 people when it started. I was down in their basement, small room, this teeny little desk, and so I really wasn't connected with the people very much initially. But I just kept at it, and I went up and talked to this person, George Cern, and where are the others? I thought there were 30 people in this cohort and stuff, and what's going on? And he decided to think, maybe, not meaning too bad, but he said, oh, a lot of them are at NAM, the National University of Mongolia. Well, they don't start school until a month after we start. And so we got a hold of Sonen Hishik. She's out in the field, and she said when they start, yeah, we'll have people in there. So I just told the students, we're not going to start. And or we're stopping until they come back. And so I ended up with 18 students in the class, and it was really fun. 5 of them maybe knew English really, really well. Some were kind of broken and some were not very good. So we'd go through a session and then I'd say, okay, tell everybody what we just talked about. And they'd get into discussions and stuff and then come back with questions. It was really enjoyable. And I think what happened is they started to appreciate that I was there to share what I knew. And the modeling aspect was not there. They did not use models very much. And I was showing them this model and that model, and they were just eating it up. So I taught 3 courses and 2 research projects and did 2 modeling workshops while I was there. So I was worn out, and we did a week up at Who School to get away and just enjoy the environment. And this is the reindeer people. They come down and during the tourist season, and note that their structure is more like a teepee. And they bring reindeer with them, and they have trinkets and stuff, and we bought a few of them, and then they invited us into their tent, and we had sutese, but I've never seen it so gray. So theirs was from reindeer, and it was a different mixture or something, but it was still pretty good. And the lake is beautiful. The horses and animals are all just wonderful to see. The Gobi Desert, we teamed up with a group from the Urbanized School of Technology, which is a branch of MUS now, and we took train for like a day or so down into the Gobi, an area called Shambhala. I don't think it's Shambhala like the song, but it's Shambhala. And it's a big monastery. And that's the monastery, and it has Wish Mountain. And the Wish Mountain is that you can walk up there. Women are only supposed to go this place, and men are supposed to go to that place. It's kind of a cultural thing. And when you get up there, there's this huge uvu, and I'll show you some other pictures. They throw rice, they throw milk, they throw candy, they throw all kinds of things around it. They put this type of stuff on there that's blue or gold, and it's kind of an energy, health, cultural, religious type of thing. It's not, I never found anything that said it was purely a religious thing or it's just a cultural thing in the studies we did. And this is what a tourist ger camp might look like. Very nice gers to stay in, and then they feed you. And oh, I gotta remember when we stayed at Who School, right? We woke up one morning and they brought fresh yogurt made from yak with the wild berries. And it was just wonderful. It was really, really good. And connection in the world. And so that's why he decided to build this here. And that has stayed in their culture and in the religion. But in the 30s, 800 monasteries existed. But in the Soviet occupation, I can't remember, not too many years after that, they went on a religious fanatic. I mean, thousands of monks were killed. All the monasteries were destroyed and torn down and burned, because they wanted to eradicate religion. So it was a really dark time in the country's history. And now, with Russia gone, they've reunited with Genghis Khan and the Khan history and all of that. And actually, Genghis Khan, they had several warring tribes in the country when he decided to, let's unite. And he united all the tribes into one solitary army. And that's when they went on their adventures, rampage, whatever you want to say, and conquered all the country. And at some sites, this one is called the Blue Heart of Black Mountain. It's where they inaugurated him as their king, as their leader. back when he united all the tribes. And so you look at all these posts, there's 29 emperors in the Khan lineage. And when you read through there, some of them lived 6 months because of the politics and contrast and conflict that would exist at different times. When we got to one place, they greeted us with, here's a couple of very, very talented guys playing the Morin Hor. We got a gift from 3 students of a Morin Hor, and to see them play, I don't know if you notice their fingers, but they're in and out and over and under and around those strings. It's amazing, the sounds that they create. It's just beautiful. And here's an uvu. You can see that they've piled rocks and there's ribbons, and if you saw close there would candy and rice and milk is distributed around the place. And then I got to visit, we've seen this recent eagle hunter video or show on TV. This is a eagle hunter's family, and in his gear in the back it's just loaded with awards and trophies. He's an amazing hunter. He even had a live fox there tied up and that he would use and stuff like that. And we talked about, you know, the economic value of what he does. He's just the pride of being a really, really good eagle hunter. They still live very simply out in the countryside. And then to celebrate when the Soviets helped them maintain their country, and especially against China, they have a Naadam festival. Every year it's like our 4th of July, and it's quite amazing. They have horse racing and archery. I went up and tried it. I've hunted a lot and stuff, and gathered a crowd because they were really surprised. I hit the target pretty well a couple of times, and I think I surprised them. And then the school kids, they prepare for this all year long. Arts in the country and in the schools are really big. Singing, music, all of that is big. And then, of course, Mongolian wrestling. This goes on all weekend, and it's amazing to watch these guys wrestle. You'd think they're not doing much, but man, it's all about, you know, leverage and stuff like that. And then a big piece of the countryside that I finally got to see last year was their biggest national park. They have a few protected areas now. Is called Relish, and this is a tourist camp and stuff. And you go into this and it's really nice, but once you go out and try in the countryside, it's all dirt roads. It's bouncing around in a vehicle or riding a horse or a camel. So it's rugged to be there. And lastly, the 3 rivers we've studied are over here in the west. And here's the big Salang Basin, that's Baikal, and that's Huskul. And for those who like to fish, this is the habitat of the taimen, are in this drainage. And then in the east, we were on the Herlin. You can see the 3 mountain ranges that I mentioned, and the Gobi region. And what that creates is 3 different drainages. So this is the called the internal. A lot of the water just goes out and disappears. It doesn't really connect. And the blue area goes north to the Arctic Ocean through Russia, through Lake Baikal, and then this area goes out to the Pacific Ocean, called the Eastern Basin. And that's what the mountains look like. We were crossing over to get to another river in the west, and just beautiful shots. And this is middle of July, so they have glacial areas that are melting and draining. And then here's another shot. And then we were actually trying to get to where this river was back together way up in the draw, and I thought this was a good view. So the mountains and the transitions are really beautiful, but there's limited. They just are wide valleys, very alluvial. So I got to talk a little bit about science, since that's what I went over there for. And with the Orhom River, when I finally connected with Sonen Hishik, we finally met, we sat down, and she started telling me she's actually a diatom biologist in river systems and water systems. And she said, well, I got this funding to do environmental low flows. And she invited a group from Spain that came for a week, showed her a model, and then they went away. And she had no idea what the model was about or anything. And she started explaining, and said, wow, I could help you with this. And she starts talking about, paying me and stuff. I said, no, I'm covered. You need to support graduate students. The students that do graduate studies there don't get funding. I mean, they just do it because they want to do it. So I kind of coaxed her into paying the students we worked with a little bit, and wow, we had a really successful project. And this is where it all kind of started, with different groups teaching and research. This is me working with a student and her advisor on her senior design, doing a hydraulic model for a dam and a potential dam site. Here are the teachers at the MUST in the environmental hydraulics group. This is the group at Erdenet Mine we worked with, and I needed Batsengel, who's my PhD student, because these guys didn't speak English. And it was really amazing to try to understand that site. Here I'm working with students out in the field. We're starting to learn how do you collect data on the river. Physical habitat was our focus. These are the two teams. We went to the Orhom. This is out on the Bolgan. This is one of the workshops on hydraulic modeling. So it was a busy time and a very rewarding time to be there. The components of our study on the Orhom dealt primarily with physical habitat and bank full, to say the physical aspects of a river really drive what the biology is. And some people come at it from the biology side, but the biology isn't there unless the physical habitat is there. And so we approached it from a physical habitat perspective. And these three gals were the only three gals that got their master's degree in the Integrated Water Resources program from that cohort. Because I really drove them. I made them read papers. I made them write. And it was, I think they weren't used to working that hard or having someone oversee their work so much. And this is Soning Hishig. She's my friend and colleague, and just a wonderful person. Here's one of our sites, the Orhom. That's our vehicle right there. And you can kind of gain a perspective of the size of the rivers. We would measure wetted widths, depths across, sediment sizes. We end up with 140 to 170 metrics at a site, and we're doing multiple sites along the river. And these guys just eat it up. They work so hard. Once you show them how to do it, man, they are doing it from dusk till dawn till we're done. And it was a joy to work with that kind of energy and enthusiasm. Here's an interesting graphic. It's a hydrograph over time, 1978 to 2008. That was the data that was available to us. But check out that low flow period. I mean, it's a whole change in regime. And so we had to account for that. And that's a big difference in these river systems. And it kind of showed up in the physical habitat. The other colors represent different pulses, orders of magnitude of flows, from extreme low flows to large floods to high flow pulses, low flows. And so we're categorically trying to link those different ranges with what's the environmental low flow to sustain ecological systems. And here's another way to look at that data on a monthly basis, where we have different percentiles of flow that exist, and you can see the seasonal variability, and we categorized it that way. And then in the river, what we're trying to do is understand what's bank full. And you can kind of see that I think this was a bank full line that was created because of the last 10 to 12 years of low flows. And before that time period, it was probably up here. So it's changed with the flow regime that's been set over these different flow periods. And what happens is bankful is reached about every 1.5 to 2 years. It gets that high and it moves the sediment and reinvigorates the stream and puts nutrients back in the stream. So that's something that really drives the biology. And so they were going to build a dam on this river. And the idea behind our work was, okay, what is the magnitude? What is the frequency? How often does it happen? And how long does it last? The duration of an environmental flow. And so that's what we worked to. The other aspect is when you build a dam is morphology, the shape. You're going to remove sediments. It's going to change how it adjusts. And we went through that. But here's kind of the picture. So here's bank flow, the flow level in cubic meters per second, the number of years over the period of record that it gets exceeded, and then what's the mean statistic of days exceeded. So when it gets there, how often does it do that in the number of years? And then how long does it last? What's the duration of a high flow? Like, what is it for us? All summer long. It's been a high flow. But we're controlling that too with the dam, because they're releasing a moderate flow that would have been higher over a shorter time, but now it's released over a longer time and staying pretty high, above bank full actually. And so what we did is characterize that magnitude, frequency, and duration. And this is what we presented at a workshop amongst the politicians and stuff, and it got some interesting feedback. A year later, we've got a couple publications out, and now it's been adopted to manage the Tule River Basin. So that's exciting, that they're actually taking into account the ecological aspects of the system before they're going to start building dams. Our next project was the NSF-sponsored project. We've finished our field work this year. I spent the month of June in Mongolia. Last year, the month of July, and then I missed a year. My student John back there has led our crew all years. He's a great student, good worker in the field. But here's our team, and in our team, we're studying fish traits. So there's a group collecting the fish and how do they feed, what type of feed do they do, what's the shape of their mouth, how do they function, are they a bottom dweller, are they a swimmer? So that's fish traits. Then there's food webs. Can we actually take the DNA and an indicator in the bugs, in the fish tissue, and in the upper ones and look at the food web and follow that in these systems? And then there's a metabolism group, they're measuring oxygen and relating it to productivity. And then there's the macroinvertebrates, the bugs that live in the stream, that feed the fish and represent the ecology. And then there's the hydro-geomorphology group. When we first got started, I didn't realize how important our group was. Everybody is depending on this hydro-geomorphology, the physical characteristics of the river, the flow, the sediment, the substrate, the riparian cover. And so we're grinding this out. And how many total sites have we done? I don't know, 80?
80 to 90.
Yeah, and we have 144 metrics at each of those sites to analyze and compare. Quite a data set. But the hypothesis that generated this was developed by Dr. Jim Thorpe out of Kansas. And back in the 70s, it was this fish zone concepts. So this is the biology perspective and trying to characterize rivers. And so you had different fish in different zones. That was theory in 75. Then you have this river continuum concept with shredders, predators, collectors, grazers, depending on upstream to downstream, and different ecoregions or the vegetation combined together. And then you had a flood pulse concept where, depending on the frequency and the magnitude of these floods, they'd blow everything out and then they'd recover and respond to the flood and the surcharge from the flood. And then the riverine productivity model, this is kind of the metabolism group. In other words, do you have the oxygen and the carbon and the nitrogen and everything to have the productivity in the river? And the concept we're trying to prove, or is our hypothesis, is called the riverine ecosystem synthesis. And an FPZ is a functional process zone. And the idea is it doesn't change from upstream to downstream. Anywhere along the system, you can have a functional process zone that's the same as this one up here, or the same as this one down here. And as long as the valley characteristics and the geomorphic characteristics are the same, we should have the same ecology in that reach. And that's what we're testing. And it shouldn't only be the same in a similar basin in the United States, but if we have the same type of basin in Mongolia, shouldn't we have the same? So that's a large scale and boundary to cross. So river continuum, things change from upstream to downstream. Riverine ecosystem, we can have patches is the word, at different locations through the stream that should be comparable. So here's our study. We've got the terminal basin, which is in Nevada, Utah, a little bit of Idaho, like the Great Salt Lake. It doesn't go anywhere. It's terminal. These rivers terminate into a big playa. They just disappear. So we did 3 rivers in the terminal basin, and then we have the mountain steppes. Most of our time was spent in Wyoming, and we went out there. I wouldn't let us sample in a lot of rivers we wanted to because there was just crazy water. I mean, it was not safe to get into. So we had to work into areas where we could get into, and we had to switch from one side of the basin to the other in the Bighorn Basin. And then here in the grasslands, we did the Niobrara and the Little Missouri rivers. And then over here in Mongolia, we're in the western or the terminal basins over there that drain together. And then the mountain steppe is in the Salang, and there are glaciers. And then here's the grasslands, which we were at this summer. Okay, so here's an example of what it might look like. These numbers represent different functional process zones. We've got valley width, valley slope, several other parameters that characterize a reach about 10 kilometers that has similar valley segments. In one of those segments, like this red one, we'll go in and pick a site, and then our reach is 40 times the wetted width. And we do 10 transects, and we collect a bunch of data to characterize the local characteristics within the valley characteristics, and then we're going to compare those in different watersheds and within the same watersheds and across continents. And here's a visual of what those might look like. Here's an upper confined reach, what you might expect. It's very rocky, bouldery, fast water. And here's an upper wide. We're just at the base of it. You can see it goes into a meadow. The water's much slower. The sediment size does tend to change. Here's a lower, but it's confined. See the geology there has trapped it. It can't escape into a floodplain. Whereas a wide reach can escape and it gets out into its floodplain. And so those are 4 general characterizations of our functional process zones. And some preliminary results of John's work. Here we're comparing subsite size, so just an individual metric, right? And we can clearly see that lower confined, lower wide are different, and upper confined is different. But the upper wide and the lower confined, so the upper wide is steeper, but has a floodplain. The lower confined doesn't have a floodplain, but it's less steep. And those are kind of overlapping with each other. They have similar substrate characteristics. And here we have thalweg depths. not a significant difference, a little bit, but not very much. And then if we go to wetted widths, wow, there's a continuum. So one of our thoughts and what we're purporting in our publication is it's not one process. It's a mixture. Different characteristics will show you a continuum. Other characteristics will show you patches that are similar in characteristic depending on the different metrics you look at. And what will be interesting is we're just looking at our geomorphology and geohydrology. How does the biology link to this now? And we just had a big meeting and we're starting to move because it's a lot of people to get together. And here's a challenge that John's been working on. And this is a comparison. It's a dendogram. Gee, I remember that. Isn't that great? So see the yellow? They're all upper confined. And the green are upper wide. The red are lower confined, the blue are lower wide. And this is with all the metrics. But in the statistical world, they start saying, well, you've got correlation between your variables and you gotta minimize that and you gotta do certain things. And so we're trying to do that by reducing the number of variables through a principal component analysis to just be the single variables that represent the different groups of data we're collecting, but we lose some of the consistency. So we're really going to try to get this out there and see what is the best way, because no one's done this. And but we definitely see differences in process zones in the upper, but the lower is kind of mixing. But this is the terminal basin. These guys aren't getting bigger. They're diminishing. And we think that might be a property of these type of basins. So here's our approach. We've got the ecoregion data. We start with the terminal basin. We got US and Mongolia, and then we got the 4 functional process zones. So we'll group the data at with these characteristics and do analysis. Then we've got continental data, the US terminal, grass, mountain, steppe, and the different process zones. And then we start with all the data, one process zone, the different ecoregions, and the different countries. So we've got a pretty good structure laid out of how to start analyzing our data, which is very large, that we hope to look at, do we get this separation of FPZs and similarity? Or what does it really tell us? Let's just go open-minded and see what the data tells us about the 2 countries. And we're looking at land cover and land use and human influence, and those kind of factors will come into play. And that's our last campsite. 23 days in and out of a little pup tent. Questions?